don't have one, I'll use, maybe borrow. If I loan this out, that means I might be calling on you for some of the answers. Okay, here we go. Okay, converse of the Pythagorean theorem. What's wrong? I don't know if I have any more extras. Okay? You'll just have to share. Okay? All right. The converse, that means we switch things around. So if c squared equals a squared plus b squared, or if a squared plus b squared equals c squared, then it is a right triangle. Okay, well, last time we said if a squared, so if we have a right triangle, then a squared plus b squared equals c squared, where c always has to be, do you remember what we call the longest side? Hypotenuse.
So we do a lot of like converse, like the
yeah. Right? Okay, so like here, and we actually did stuff like this in the previous lesson, okay? So it's like a continuation of the same thing,
sure you know?
All right? So take this example. If we have sides that are 12, 16, and 20, we want to show that it's a right triangle. Now, where would the right angle possibly be here?
I'm just guessing 16.
16?
I have no idea.
I think
20. C.
I think A.
What has to be the largest side?
The
C.
The 20?
Right? So this would have to be C. And then does it matter which two are the other sides? We can call this A and this B. So we want to see, is A squared plus B squared, does that equal C squared?
A squared plus B squared, I've heard that before.
So 12 squared plus 16 squared, is that equal to 20 squared? Okay, now that you have to show it. You can't just say yes or no. But this is where if you have a calculator, so 12 squared is 144. 16 squared, I gave away my calculator.
I got it.
Come on, Fred.
What's your 56?
256.
You don't even have a mini? You know the little one?
No.
Yeah.
And 20 squared is 400. Okay.
Yeah.
So the question is, are they equal?
Yeah.
Aiden says yes, they are. So 400 equals 400. I'm going to put a little check mark. So we have shown that this is a right angle here at C.
Wait, I have a question.
Yeah.
How can we put the C
You'll
on the BA?
Okay.
Because it's the...
You're going to see, I'm going to rewrite the next ones. So we don't always have a right triangle. We could have an obtuse triangle, or we could have an acute triangle. Okay? So there's a reason I put the C on the left side. When we think of acute, we think smaller than 90, right? Less than. So if C squared is less than A squared plus B squared, then it's an acute triangle.
Whoa. And if C equals A squared plus B squared, equal.
Okay, so not equilateral, but what did we?
Right angle.
Right angle. So if it's equal to, it's a right triangle. And then if C squared is bigger than A squared plus B squared, what's the big angles are called? Obtuse. Okay, so that's why I write it in the other way. Also think converse, right? We switch things around. So that's why I'm going to put the C squared on the left side. Okay, but we don't know which ones are A, B, and C, and sometimes we have a radical. So we have to, I know, but okay, is 5 the biggest, 4 the biggest, or the square root of 35? Okay, those of you that have calculators, what is square root of 35?
5.9.
Approximately. So it's about 5.9 if we do the
right.
square root on the calculator. Do control.
Wait, why is it 5?
X squared. So there's a control button at the left, the top
Yeah.
left.
Square root of 35?
Maybe, yeah.
So if we do control X squared, that will make a square root. Okay. Why do we do that? Because we have to figure out which one is going to be our C. So
Wait, no, but c squared equals b squared equals a squared.
So this is, I know, but we have to do c squared compared to, so kind of like, I don't know what's going to go in between. I don't know if it's going to be equal. I don't know if it's going to be less than. I don't know if it's be greater than.
What's this squiggly?
That's just approximation.
The approximation is about
Like
six.
rounded. Okay, does it matter if I put 4 squared plus 5 squared or 5 squared plus 4 squared? Nope. Oh, wait, sorry. I didn't mean to do that. I meant to put square root of 35 squared. The box, okay, the inside the box, bless you. If it's less than, it's acute. If it's equal to, it's right.
Oh.
If it's, I'm just saying, like, I don't know. I'm not going to put an equal sign because I'm not going to put an equal sign because I don't know if it's equal.
Wait, what are you doing?
So wait, it's 41. But you know,
Okay.
4 plus 5 squared
Why is
equals
it in
41.
parentheses?
Well, what happens when I take a square root
41.
and then I square it?
Oh, it just becomes. Can you?
They just cancel.
5 squared is 35.
Good. So I just get 35.
35.
Okay. 16.
Well, the one on the right is greater.
So many accusations.
Okay. So 35.
Plus 41.
Okay. 41 is on the right side. If it's less than, we said what kind of triangle is it going to be? Acute. Okay, the next one, all right, we don't have any square roots on this one, so that kind of makes it a little easier. We can see that C is going to be 15. So I want to see, how does 15 squared compare to 8 squared and 12 squared? Yeah.
I don't understand. Why are you putting on the first one? Why did you put that in parentheses?
You didn't have to. It's just because it's a square root.
And
Okay.
you don't do 5 squared plus 4 squared equals 5.9 squared. You don't do that. Where do you get 224?
Well, we're trying to see what they're equal to. So-
What's the point of making 35 into 5.9?
Because I needed to see which one was the biggest side.
Am I right?
Okay, 225. How does 225 compare to the right side? What's 64 plus 144? Anybody add that together?
208.
208, which makes this greater than. So if C squared is bigger than the A squared plus the B squared, it is obtuse. Okay.
Of course.
All right.
Wait,
Wait, what?
how
It's this?
do you know
Obtuse.
whether to do it as equals to zero?
We don't. So, okay, guys, last class, they were always equal to, okay? Because I gave you a right triangle. But this way, we don't know. That's why I don't put it. Listen, you can put an equal sign. I could do like this. I could say like 8 squared. I could put a question mark. But do I know if it's equal to?
No.
No, I'm trying to see if they're equal to, less than, or greater than. But what do I always have to compare A squared plus B squared to? I have to compare it to C squared. So that's why I always put the biggest side squared on the left. What do we get for 8 squared? 64.
So 64 is greater than 61.
Okay, so 64, 25, and 36.
Does C always come
61.
first in this case?
So I'm going to put greater than, which makes it obtuse. Good. Okay, so I'm comparing. So this time I put a question mark. But do you see how I don't want to put equals? These are not equal to each other, are they? Oh, Leah, can you see? Around Mark.
Oh, no, I already did it.
No. Leah's trying to see around you. That was all. She's good. Okay, which one is C this time? 17. So I want to see, how does 17 squared? That's why I put this little box.
Wait.
Oh, what'd you get, Aiden?
Right.
Right triangle.
Right triangle, because we get 289 here.
Why is C obtuse if B is right? Like that doesn't make sense to me.
Because we guys are cute. That's weird.
Okay, I'm sorry, Minnie, go ahead.
Wait, so why is C obtuse and B is right?
Why is C obtuse? Because C squared is bigger than A squared plus B squared.
So if it equals
Wait, but wait for
Wait, so how do I do the
for
square
B, what's 225 and 200
Oh, what about this?
or 208?
Well, 225 is
cancels it out.
bigger than 208.
Isn't that like the same thing as C though?
I don't know.
Wait, 225 is bigger.
Yeah, so B and C were both obtuse.
Oh, they're both. Oh, I thought it was.
Yeah, this one was greater than and this one was greater
Oh, I
than. So
thought-
both
I
of
thought
these
so.
are
it's
Right.
greater than each other. Like if,
Yeah.
if the number's like bigger number's greater than that.
And on the homework, I actually have it like in the directions. So it'll say if C squared is less than, you're going to write acute. If it says C squared
the
is
backside?
equal to, it's going to say right. And if it's C squared is greater than, it's going to say you're going to put obtuse.
Guess the backside. Oh, the bottom part's gonna be right.
Oh, come on. All right, example 3. Same thing. Same thing, I just didn't give you a picture this time.
Why not?
So, what do I have to, I just have to figure out what do I have to make C equal to? The biggest side. So in this case, C has to be 35. So I want to see how does 35 squared,
Equal 36.
what? Squared. What's 35 squared? These are big numbers, it's fine.
It's 441. Our big boys.
Where's 441? Oh, here, 441 plus, what was it?
784. 780.
784?
700.
What?
1,000.
And what did we get for 35 squared?
1,225. Is this the same thing as
No, it's
before?
1,225.
So 1,225 compared to 441 plus 784. Ah, they're equal, so that makes it a right angle. Okay, which one is the biggest side here? Square root of 13, 6, or 7? Okay, what's square root of 13? If we're not sure,
I think
169.
what did we get?
169. Or,
No, 13. This is about 3.6.
well, yeah.
So what's the biggest side?
7.
7.
Well, you lied to me, Gilbert.
So 7 squared, how does that compare to the square root of 13 squared?
49.
So 49
No, you goofy goober.
6 squared.
plus 36.
I don't wait for the ones with the square roots. Like
Yeah.
when you get
13.
those, what do you do with that? They just cross out.
Yeah, so a square root and square just cancel each other out. So if you have something under a square root and then you square it, you're just left with that number. Whereas,
Oh, it's a right.
oh, it's also a right angle because they are equal. So these are equal, so this is a right triangle. Okay, 2 more of these. We're going to skip example 4 and then we'll just do a couple. Okay, which obviously the biggest one here is 145. Big numbers here, but that's okay. That's why you need to have the calculator. 17 squared plus 144 squared. Ugh, horrible big numbers.
21,025.
What is it?
21,000.
21,025. Okay.
It's the exact same thing.
Is it a right triangle again?
Yes.
Oh, yeah. What's 144 squared? Lev knows this off the top of his head.
I also do.
Nope. David,
20,736.
what is it?
20,736. 144 squared is 20,736.
And we get the same thing? Do we agree?
Yeah.
Cool.
145 squared is 21,000.
So this is also a right triangle. Okay, last one. Which one has to be the C? The 5.5. I know. What's going on out there?
They're all the same. How do you know which one's C?
It's the big. What do you mean if they're all the? Well, then it can't be a
Wait, why did you give me that look?
If it's equilateral, the angles have to be 60.
Wait, 5. Oh, it's 5.5. I thought it was 5.
Oh, 5.5.
Nope, it's 5.5.
All of these are like right angles.
Oh, is this one a right angle too? What's
No.
5.5 squared?
Obtuse.
Left angle.
It is
30.25.
30.25. Wait, what do you do for D? That's so confusing.
So then.
So this will be 5 and this will be 25.
So that would be 30. So 30.25 equals.
It's greater than.
Why are you doing? Wait, one of them's 5.5.
5.5. Yeah, so 5.5 is the biggest one.
So that's obtuse.
So these are all the same. Just some of them I gave you a picture, some of them I didn't.
Wait, so how do you know if it's a cube then?
Yeah.
Oh, if it's less than.
What?
Like let's say we got let's say we
So your
get
biggest number
28
is
here.
lower than the actual number, so.
Yeah, if we got 28 for this one, then it would be a cube.
Alright, can we do the homework now?
Okay, we're gonna cross this
That
out.
one's obtuse.
This last one was obtuse.
The graph? I can do the graph.
You want to do the graph?
No, I think
No.
we should.
No, can we not?
Okay.
Well, let's do it.
No.
Okay, for just quick review, square root. It's okay. Come on, we got to be able to do this.
Oh.
This is one of the things that you have to be able to do in Algebra 2 next year or intermediate. So you have to, everybody wants to graduate. 78, what goes into 78? 39 and 2?
How do we know? Is this the calculator?
Yeah. So 30, whoops, sorry.
Some things you're forced to do, you know what I mean?
2 times 39, but then 39 is just 3 times 13. Do we have any pairs? No. So what do we do if there's nothing to break
Just
down?
delete it.
Then it just, that's our answer.
Oh, so you can't do it.
Yeah.
But
If you remember on the quiz, I think I had on one quiz, it was like square root of 23. And the other one was like square root of,
It was no, I remember. No, one of
17.
them. Yeah, it was just square root of the team.
yeah. And there's just leave it, right?
Here's the map. How do you do this fraction?
Well, I didn't get there yet, love.
That'd be useful.
Okay. What goes into 148?
74.
4 and what? 4 is easy. 4 goes into 148 how many times?
0.25. Blue, I got it. Wait, hold on.
Fred, I gave you my calculator.
37.
Whoa.
No,
I
37.
did
I did a
27.
problem.
It's 37.
Oh yeah, no,
37.
37.
Can you
Yeah,
not
I
do
said
74?
Oh,
and two?
okay.
Sorry.
Someone else said a different answer, Fred. I'm sorry.
Wait, Miss Casey, I did
Would you
74
say
times 2, and then I did 37 for 74 times.
Oh, that's so. This is
You
so
did it
interesting
right.
because I did it like.
Did you do 74 and 2?
37 and 2.
Okay, but then do you still end up with a pair of 2s?
Yeah, because of 4.
15 minutes.
Okay. Last 2 problems. I'll have time to do the homework. Okay. When I have a square root, what I want you to do, I want you to do the square root of the top
Square root of the bottom.
and square root of the bottom. Now, conveniently, yes, I did this on purpose, even on the homework. I always give you a perfect square in the bottom. So the bottom's going to be the easy part. That's just going to be 5.
So wouldn't you just do like
So-
4 times root 2?
Yeah, what would, not 4 times root 2.
4 root 2. Maybe root 5.
2 root 4.
2 root 4.
Okay, hold on.
Guys, you're
It's
8.
going to be 2 root 4.
No, 2.
Wait.
And then
2.
wrong.
You have a pair of 2s, 2 root 2.
2 root 2.
Human calculator Lev over
That's
there.
what I just said.
Oh, I'm sorry,
That was a
Avery.
good point.
He yelled it. I wasn't expecting it to come from that direction. So,
Whoa. Shots
but
fired.
he looks very. Does he not look a little too relaxed?
Who?
Sometimes you have to be relaxed to get the right answer.
Okay,
It's a perfect one. It's
fair
like-
point. Fair point.
it's
Okay.
over 700.
Square root of 100 over square root of 49. Oh, these are both perfect squares, so we get
10. Yeah.
perfect.
These are both. Oh,